Yeah, hello everyone. My name is Hauke Fuhrmann from Scheidt and Bachmann Systemtechnik GmbH in Kiel in Germany. And next to me is my colleague.
Yes, I'm Niklas Renz. I'm researching for this in this relationship.
Okay, so today we want to talk about a project called Visible Code. It's a project about to visualize complex, let's say, modular software projects. And in particular, this is today for OSGi projects. And now I want to give the industry motivation for this. And afterwards, I will hand over to Niklas, who will present the state of this project and give a demo about it. Okay, so let's hop in. So let's see if we have the chat. Okay, so here we are. So the question is, who are we? We are a medium-sized company with about 3,000 employees and have a worldwide presence in about 50 countries. So we have 4 divisions, one for parking solutions, one for fare collection systems, for fuel retail solutions. And the thing I want to talk about today is signaling systems. So in the Kiel area, we only are working about signaling systems. So the domain is railway here. So what do? We build signaling system that is control and operating systems, centers, for example, and we have 2 flagship products, the level crossing and a digital interlocking system. We have maintenance-free field elements, operation and interlocking simulator, and we do planning and construction of level crossings and signal boxes, and involved in the European train control system. So in short, well, we have 2 parts mainly. And the first part is we build safety critical signaling systems. So we build signaling components to control trains, like the signals you see here, or we control switch points and so on. We do not build the trains themselves. But I don't want to talk about this. I want to talk more about train management systems. So here on the left, for example, we have a train management system of Deutsche Bahn. This is the control system in Duisburg, I think. And on the right hand, we see one for a metropolitan railway, the Hamburger Hochbahn. And what you see is it looks somewhat like this. So here you see the Columbus control room. So what you might imagine is that these systems are very, very complex, and we don't build them in a safety critical way. I would say it's hardly possible. It's a very distributed system with many servers, many clients, and a rich client interactive graphical screen and so on. So we have a really complex system here. We build it with OSGi mainly, some of them. So we have some example code bases here to give you an idea on how complex this is. So for example, one train management system, and it's only a web interface here, has about 87 bundles, external libraries, then orthogonal to that, service interfaces, service components, and consumers of components. And that's about 1 million lines of code, which is only 650,000 productive, which is then without blank lines and comments. And there's about half of the code is Java code. And another system is an operator station. It's a distributed system. So here we have other numbers. So we have 13 products here because we have different kinds of computers involved. We have another number for bundled service interfaces and so on. And we have about 2 million lines of code. And the last one is a rich client configuration application that is only located on one PC. But it has about 5 million lines of code and different numbers of bundles, interfaces, components, and so on. So you see there's a very different granularity of the OSGi configuration here. So these systems are really complex for us. And of course, we try to document them, and we try to get an idea about the OSGi architecture. So what do we do about this? So we draw diagrams manually. And we do this, for example, here we have a diagram drawn with a standard UML tool. So we use UML component diagrams for that. So never mind the concrete contents here. It's just to give you an idea what those diagrams can look like. So you see boxes which represent service interfaces or service components. So implementations of those interfaces and the dependencies between them. And we have many of them for different aspects of our applications, of course. So we have, of course, limitations of that approach. The diagrams are drawn manually, so it's very, very effort prone. They get inconsistent to the code base very quickly, and they are usually not exhaustive. You never see the whole picture of the system. And they usually do not scale, so you can only show a small part of the system. And in these particular diagrams, we only showed services and the dependencies, and we didn't show products and feature bundle interdependencies. This only shows the architectural overview, but we don't know anything about what's going on when an OSGi system is running, so nothing about runtime behavior. And if you want to really do something with the diagrams, for example, you want to document the current state of an implementation, it's a manual process. You have to do it manually. On the other hand, if you want to document an architecture set point, so what should the architecture look like, and want to check or compare that to an implementation, that's also a manual process. Some related work was, for example, here you see some plugin for the Apache Felix web console. It's called X-Ray by Peter Kriens. It's a rather old approach here. And that shows information from within an OSGi application running. But that was not what we wanted. So our goals for a new approach, we stated those, gave that to the University of Kiel and made this project. So our goals were 3. So the first one, we wanted to document a code base automatically. So no manually drawn diagrams. So we want to generate diagrams. And we want to show services as well as the product bundle feature interdependencies. And we want to extract the data from a workspace of a developer and not at runtime of the application. So we can really get this in advance and not only when the system is running. And we want to combine multiple products, not only one product, but we have multiple projects in one products in one project, and maybe even multiple repositories, source code repositories. Another one is we want to do architecture set point documentation. We want to save diagrams and compare them in different versions. And we want to draw the diagrams in advance and then compare them later on against the implementation. And then we want to actually we want to do a runtime situation analysis. So additionally, we want to get information from a running application. So for example, to see state of bundles and state of services. Yeah, that's when Nicholas comes in and yeah, creates this nice project he wants to present you.
Yes, thank you for this introduction. So now I'll take over. And with all these goals that we got from Scheidt and Bachmann that we need to fulfill, one of the first things that one might say, okay, we gather all the data and take this data and then just throw it on the screen, but maybe this is not what we want to have, as this is just too much information on one place at this time, and you can't really gather any details from this. So a very important aspect for such documentary views or such a visualization is that it is interactive, and of course that views can be filtered. So the filtering is very important here. There has already in the academic world been some research, such as this work, which has been presented on the VisSoft conference in 2016 by Zaida et al., where they visualized different metrics of bundles and also of service components for OSGi projects. And they extended this work in the later years, for example, with this in 2018 with some virtual reality and artificial reality tools, so that developers can really get a grasp of the software projects by using these technologies. But for most developers, such technologies for virtual reality are not as available while programming. So we have an own approach which has been presented this year, last month, on an academic conference, where we try to use well-accepted visual concepts to visualize statically analyzed projects, and in the future also more. So our approach states as a first thing that we want to have a good comprehension of the dependencies and between, for example, bundles in OSGi and between services and how everything connects. For that, we mainly use the Eclipse Layout Kernel. That is a layout framework that can be used to lay out arbitrary graphs. And this Eclipse Layout Kernel, for example, has also been presented here on the EclipseCon back in 2016. So maybe some of you may remember what this framework is about. And another thing that is very important, as we've seen in the first picture, that filtered views are very important. So we need to provide these in our approach. Furthermore, we want to be able to explore the diagram interactively and not have everything in there at once, but view whatever we want to view at that point in time. Furthermore, we want the views to be reproducible. So yeah, and with this reproducibility, also that this can be used for documentary purposes, so that we are able to configure some visualization for a project that should be reproducible for different states of the project, and that can then be documented on some documentation sites to be viewed by architects and programmers in the project. And all of this that we have is also completely open source and can be worked on not only by us, but also by others, which I think this is an interesting concept for these visualizations for OSGi architectures. Let me now have a quick dive into how we do this using different models. So as a first thing, when we have an OSGi project, this is most likely in some repository, and there is code and files that define this inside this project. So we wrote a generator that uses the configuration files for PDE projects that we currently can use, and put that into this kind of architectural model, where every information that we want to gather and can visualize with this visualization is stored and persisted inside a model file. For this, we use EMF tools. So this is all well within the Eclipse framework, within the Eclipse economy, and working well together up until here. Then as a next part, we use this data from this architectural model and use that inside a visualization context model, as we call it. And this is a model that is telling the viewlator which parts of the architecture should be shown at the moment. So all the filtering that should be applied is in there, and parts and connections that should be shown are inside this model. This is then the model that in reality is visualized on the view. As I said already, this is done by using automatic layout using the Eclipse Layout Kernel, as well as the Kiel lightweight diagrams framework that we use for rendering and other stuff in the background, and for the interactivity with these diagrams. So these views, then there's the user who can modify this model that is visualized directly inside this view via filtering technologies and other interactions, so that the parts can be shown that the user wants them to show. And this visualization context model itself can be persisted into a file as well. So with this concept, we are able to, for example, have this project generate an architecture model, maybe daily, inside a build job, so that we can use this visualization context model, persist it in a file, and use the new data from the new model and have an updated view that we configured once and then can use with the new data from this architecture model later again. So this is the important aspect, that the manual documentation will get old maybe, but this kind of automatic documentation will stay up to date. So as the next part, let me show you a quick demo of how this visualization looks like. So now you are viewing an Eclipse development environment where we have a diagram view, and inside this diagram view, we visualize the default view of our project. So here we have, for example, a project that visualizes how a translator service with different translators is shown. So here's an overview, and we can have a look at what products are defined in here, what bundles we have, the services defined within this project, the features from the PDE tooling, and also some other overviews about bundle categories, for example. So as a developer or as an architect who wants to create such a view, might want to have a look at, for example, how the bundles look like. So we can have a look at these bundles. The animations shown here are through Zoom and everything today a little jagged, but usually these animations are also smooth to keep to be able to keep the mental model of the user. So okay, now we can see here we have this bundle overview, and inside this view via containment we show all the bundles that are contained in this project. So this is one kind of interaction that we really could click inside the diagram and modify it with that. Another part how we can modify is with this sidebar, and inside this sidebar we can, for example, have a look at different options that can modify this view. For example, here we can see all the bundles that we define ourselves within this project. All these blue ones and these very light blue ones are external bundles that are referenced by the project. Maybe we want to know at first have a look at only the elements that we define ourselves. So we click at this view filter external elements to move them out of the way, and now we have only the view on all these bundles. As a developer, maybe we might want to have an overview of how everything connects. So we have a button up here that just shows all bundle and package dependencies that are in this project. So now here we can see via connections. For example, here we have a connection from this German to English translation bundle that goes all the way over here to this model bundle. And this just shows that this bundle requires this bundle. And the same applies for all these packages. So we also have package dependencies from bundles to other direct packages that are not defined in bundles here, or package dependencies that are defined from other bundles here. So now we also have some description texts that we got from the files here. And okay, so this bundle contains the generic classes for translating German to English. Could be quite nice if we want to take this talk in German and we use this bundle, so you all understand us, but for now we do this in a usual way. So okay, description text such as these we can also in this filter view turn off, so we have a smoother look at only what interests us at the time. Okay, so now we may want to have a deeper look at this one bundle, so we can undo what we last did in the view and not show everything, but as a next part, just have a look at this bundle individually. So from here on, we can say, okay, show me every package and every bundle that this one defines by clicking on this black rectangle and circle on the sides here. And with that, we can click our way into a view where we can see everything that is connected to exactly this bundle. Okay, so this might be a view that's interesting. So how does this bundle connect, or maybe other stuff that a developer or an architect might want to have a look at? But something that's different for OSGi is, okay, OSGi is focused on services. So let's have a look at the service overview. So we can check a checkbox here to be able to show the service overviews within bundles. So we have a look at this. And here we can see every service interface and component that is directly related to this bundle. So we see here, we have this German to English translator component that is defined by this bundle. And maybe we want to have a look at who says how this component runs and what is required by that. So we may have a look at the service overview up here. Click on this down here to get the matching one up here. All right, so here we can have a look at this German to English translator, and also likewise with the bundles, we can have a look at how this connects to other interfaces. So this component requires some language database provider interface, which in turn is provided by this file-based language database loader component. So this component is also defined by some bundle. We can have a look at that via another view option that is available here. So right now we have the same view where this German to English translator component uses this interface, which is defined by the loader for language database bundle. And we can have a look at that. Okay, that's definitely another bundle that is not inside the direct hierarchy, but is also required to have a look at when we want to know how this German to English translation bundle really runs. Okay, so for getting these views so that they can be restored, we have a store view model button here, which we can click. And now we reset the view, and we can just load the stored view directly and get back to the view that we had before for the documentary purpose, that we can now view exactly what the architect wanted us to see about this project. So this is available right here. Okay, let me go back to the slides. So we are also able to view exactly this view with the same interactivity, not within Eclipse, but here within some browser. We have a browser. This is the Theia IDE, which you probably have seen some of during the EclipseCon already, and we'll be seeing the next days as well. So this is also possible. So as a quick recap, what have we seen already for the concepts that we have? As one thing, yes, we can see the containment. So we have this project, for example, here, and contained within that are these bundles. Another thing that we saw are the connections. So we connect, for example, bundle dependencies and also services by edges here. We are also able to filter the view to only look at what we really want to look at the time, and also many more things such as some focus and context. So we can click on elements and get the focus and get the context that we need to view at the time. We use the automatic layout for a live view of the models that is generated directly before your eyes. Yes, also we use transient views. So these views are generated automatically, and we are able to use different user stories. So we allow for interactive exploration of the models, and also we allow for documentary views of these. So this is a basic overview of how architectures in OSGi look like. We have the service layer with interfaces and objects, and they can connect to each other. And we have the module layer with bundles and features and projects as a hierarchy, and these can depend on each other. But we may as well have a look at other frameworks other than OSGi. If we rename these and take, for example, arbitrary artifacts and services and how they could connect. Or if we don't have services, we could remove that as well and just say, okay, maybe we want to have a visualization about some products and artifacts and how they correlate with each other. So this is something that we are able to visualize as well with the same concepts as we've shown for OSGi here. So we are not only able to show the views for OSGi, but we may also be able in the future to have the same visualizations, for example, such as here for the Conan's Conan.io or C++ package manager, or for the NPM package manager. Some parts such as these, we can generate similar visualizations. So yeah, as parts of the future work, yes, we want to be able to extract this core functionality that I've shown on the demo, so be visualizable in the future as well, in other frameworks as well. We want to have a view. We have the documentation not only being visible within Eclipse, but also within some arbitrary browser views, or also within other IDEs such as VS Code. And in the future, we want to get a deeper focus on how we analyze the data during the runtime, so we can visualize what we have in the what we can visualize during the runtime, and everything that's interesting for the industry and other people are there, and much more. So there's a lot that can be done in the future, and we will also do in the future. So for now, I want to say thank you for listening to this talk. You can contact us directly via mail, or also join our project on GitHub, where all the source code that we use is located in. And yeah, with that, I want to start answering some questions. So I can see we already started with questions. So I've got a question from Andreas Schwarz. Is it possible to visualize services that are registered manually and not declared via DS2? I'm not quite sure what DS is doing. No?
I think at the moment not actually, because we have some generator that generates stuff, and we implemented so far only the XML way of declarative services. And we also implemented the way of referencing services through the E4 framework. So E4 RCP reference services, for example, are also noticed. So that's, I think, manually is something that's not in there. And it's only working yet for PDE tooling, not, for example, for BND. That's also something that we would require another generator for that information. So that's where we hope that somebody kicks in and just helps to make the tool better.
Yes. Good. So we got another question from Thomas Driesen. Just to get this right, the data for the model is generated and at build time and not retrieved at runtime. Yes, currently we have views that use the data and the files that of the project, and that is analyzed statically directly. So we are able to visualize that, and we're not able yet to visualize any runtime data. That is part of the future work for us, as we focused on these static contexts for now. What was it again? Yeah, I think that answers that question. We got another question from Amit Kumar Mondal. Does it also work with RegCap model as well? I'm sorry, I don't recognize what RegCap models are. So
I think that's the requirement capabilities, I guess.
Oh, okay.
I think actually that's not yet in the generator, and I think we don't have that yet in our OSGi model. But at least the mechanisms for doing the graphics and the animations are all there, so it's easy to just extend the model, and then to let Niklas add that documentation. So we need to extract the information into the model, and then we could easily visualize anything there. Yeah.
We can also think about directly if we are within an Eclipse environment and have the model in there, that the model that we visualize is generated live from the files that are within the project, and visualize that directly. But currently this is via calling the generator tool directly and using the output model and visualize that. So this is how we do this. Okay, with that, I think we are out of time for this session. So thank you again, and I will give it back to the organizers. Thank you.
See ya.
Bye.
Goodbye.